There we go. So hopefully those still in attendance are seeing the moderator slides if I've shared the right screen.
I was just about to hit share screen because I had to move this one out of the way, so we didn't have like a. Do you want me to go ahead and do it?
Yeah, so I want, and I'll do this once more before the session starts. If you haven't gotten a chance to thank the sponsors, please do. Even though virtual events have a lower overhead than in-person events, they are not free. This stuff still costs money. So thanks to all these folks for giving us the ability to hang out and learn stuff this day. Kathi, you can go ahead and take it back now.
Okay, just for a second. Screen one share. So you should see my slides.
Looks good. Yep.
And then if I hit escape and bring this up, you should see SSMS.
Yep. Looks good.
Okay, I can unshare now if you want the vendor.
Sure. Yeah.
Okay. I like how that middle one is like Redgate red.
Yeah, it's I don't know if it's the same Pantone code, but it's close.
Probably not exactly, but it's close.
Yeah, it's been yeah, I'll say not only for GroupBy, but a lot of other events. Redgate's really stepped up, these last 18 plus months now. A lot of these virtual events have either had sponsorship help from you guys or behind the scenes help or both. So thank you for that. Because yeah, I think some people operate under the impression that we can do an online event for no money, and you can do it for not a ton of money, but not no money.
Right. Yeah, I mean, that's one of the reasons I really love Redgate is the community aspect of the company. And it's, been that way for as long as I can remember. So
yeah, I never remember going to any SQL events and not seeing Redgate being a part of them.
yeah, I mean, back in the day, there were so many SQL Saturdays. I don't think we were involved with all of them, but if one of us was actually going there speaking, we would typically sponsor.
Yeah.
So, I mean, there were so many SQL Saturdays at one time.
Yes. Yeah, it would be, hopefully we'll be able to get back to those days. Because yeah, it was, I don't know, I always thought that was cool. When I learned about Past Summit, I didn't know SQL Saturday was a thing. Like the first event I went to was Summit, and I basically went for trading. My boss is like, you have X amount of money. I was like, well, this seems like a good thing because there's a whole bunch of people, speaking on a bunch of stuff. And then when I was at Summit, I learned about, SQL Saturdays, and yeah, I mean, there was one pretty much anywhere that you might ever want to go for any reason.
So would you say that it changed your life?
Oh goodness. Oh yeah. I mean, I've said that like every session I start. There's no question about that. I mean, I went to the summit in Charlotte, and
that was a good one.
I didn't know anybody. I had read some people's blogs and stuff, didn't know a soul, and didn't really introduce myself to anybody there. I just went to all the sessions, went to my room, and that was it. But I mean, that started the course to the last 3 jobs I've had, and all sorts of cool stuff, volunteering for events, speaking at events, traveling to get to all that. Yeah, changed my life is absolutely true. And, it still has the capability to do that. I know obviously the travel is less, and it's a little bit harder to meet people at an event when it's virtual, but you can still make connections at these that, maybe it solves a problem at work for you. Maybe it makes an introduction that leads to a new role for you, or maybe you've made a friend, or who knows. Like I said, I think the worst case when you when you're involved with an event like this, the worst case is you probably learn something you didn't know. The
It
best
is the
case is
worst
so
case.
much more. Yeah.
Yeah, I really feel like for me, two things that really changed my life and got me to where I am today. One is originally going to Pass Summit starting in 2003, and the other one is singing in public.
Yeah.
Really have to also say that's made a difference. Seems crazy, but it just boosted my confidence to where I could be brave enough to speak in public, I guess.
Yeah. Yeah, I think the first I saw, I don't know if it was in Charlotte or the next, because I went to Seattle the next year. But I remember seeing a windowing function talk of yours. And I remember you talking about singing and karaoke and all that. Yeah.
Yeah, in Charlotte. So I had like 30 minutes, or there was a really long period of time between the last speaker and my session. So I had everything set up well, like 15 minutes early. And I was just talking to some of the people in the room, and someone yelled, "Sing for us." And so I did, and it was before,
Awesome.
not during the session. So, so you may have been there for that. But
yeah, I honestly don't remember. It was one of those first 2 years. I remember that, but I don't remember which place.
Yeah,
but
so
I might have been there. Yeah.
Yeah, I might have talked about it in others, but I did sing during that one. But so what was really crazy is different pictures are popping up on Facebook or for different reasons, and we're in the pictures and we don't know each other at that point.
Yes. Yeah.
We used to work at the same company, evidently.
Well, we certainly ran in the same circles a bit, but yeah, it's yeah, and it's funny now that it's kind of end of October into November. I see a lot of people posting like old Past Summit memories because it's kind of around that time.
Right.
So yeah, I'm glad it kind of, the online event falls on roughly the right dates this year.
Similar dates, yeah.
Yeah.
But yeah, my memory, like those Facebook memories, I see. Evidently, I just spend all of my time traveling before the pandemic because it's like every day, it's like, 2 years ago you were in this city, and 3 years ago you were in this other city. And so I guess that's the way it was. But I was like, wow, my life used to be so much more fun than it is now.
That's almost the only reason I stay on there is, and I'm sure there's other ways to solve this, but it's such an easy way to catalog places I've been.
Yeah.
I don't use it. I don't use it for much. Yeah, but yeah, for that, it is cool to go back and kind of look at those. And yeah, hopefully as we get into next year, some more of that can start. I know, I was at Data Mines a couple weeks ago. That was in person. I see there's a handful of events in the UK. I think Scottish Summit in February is in person. So maybe next year sees some semblance of normality for stuff like that. We shall see.
So it kind of like, my brain is kind of like different now. Now it's like traveling someplace. I don't know. I'd rather stay home. I think my brain is just kind of gotten a little messed up as far as travel, just because of the last 2 years, even though I have been on like 6 trips this year. So
yeah, the last part of this year's been a little more normal. Like I'm speaking in Orlando this weekend, so that feels normal to get emails from Delta saying be ready for your trip. The emails are a lot longer now because there's a lot more rules, but that's nice. Yeah. I can't remember if Redgate's a sponsor there. I want to say yes, but I'm not certain.
I think so.
I know Steve's speaking.
So probably so. I was gonna speak, but then a lot of things got kind of messed up. Personally, I thought I wasn't going to be able to go, so I canceled, and then that thing got canceled, and so I'm like, oh well. But
yeah, I feel like that pretty well describes the last 18 to 21 months of not so much in-person stuff, but yeah, you know, everybody's calendars got pretty fluid because
Yeah.
yeah, there's been some stuff. It's like, well, you're gonna get to go do that. No, just kidding. We're not gonna have that. So yeah,
Mhm.
it's been interesting. But yeah, my travel apps actually have stuff in them for this week,
Yay.
which is rare. I'm going to turn the screen sharing back over to you now, but I will remind everybody again, buy stuff from the sponsors. And if not that, please just reach out to them online and thank them for doing this. But yeah, I'll turn it back over to you now. How do you want to do questions?
So typically I'll talk about a topic and then I'll have a demo. And after the demo, I'll probably say, Matt, are there any questions?
Okay.
And I can always go back and rerun a demo or pop back to the slides or whatever to answer the question if need be. But
Okay.
That's when I'd like them.
Do you want, obviously people are welcome and encouraged to drop those in chat and I'll kind of collect them for those breaks. Are you okay with people at that point unmuting and acting like we're in the same room? Obviously on the breaks, not just shouting out right in the middle of the session. But,
right. Yeah, I think that would be fine.
Okay.
That'd be fine. Sometimes the questions, when people type it in, it's really hard to understand what they actually mean sometimes.
Yeah.
So it might be useful to go ahead and just, have them raise their hand and you can just let them in.
For sure. Okay. Well, it is 3:30. So I'm going to turn my video and mic off and watch the chat, and it is over to you.
All right. Thanks, Matt. Hey, everybody. Welcome to T-SQL Window Function Performance. I'm Kathi Kellenberger, and I work for Redgate Software. And I just remembered I did not add those extra slides I was supposed to add. This is a little bit about me. I am the editor of Simple Talk at Redgate, a co-leader of the data platform WIT group, and had been co-leader of the PASS WIT group as well, going back a few years. The most important thing I do in my life is that I'm an instructor at an organization called LaunchCode, which provides free training in St. Louis and several other cities around the US to get folks into tech careers, people that just have not had the right training or the right opportunities. And I'm just really proud of the work I've done there. I have seen lives completely turned around for the better. I'm also a lifelong learner and teacher. And if you need to reach out to me, there's my address at Redgate. And I want to remind everyone about the PASS Data Community Summit that's online in a couple of weeks. And you might have heard Matt and I talking about this coming up in a couple weeks. This time it is sponsored by Redgate. However, we're trying to make it as community focused as possible. So we would love for you to sign up and attend. And I would love to see you there. So I'm going to start by talking a little bit about what window functions are. I'm kind of assuming that you know what they are. I do give another session on the introduction to the topic. Today I'm talking about the performance. So this is kind of the second session in the series. And actually there's three sessions in this series on window functions that I talk about. So what in the world are these things? At the beginning, when I first started talking about them about 2012 or 2013, a lot of people thought they had something to do with the Windows operating system, but they really don't. They are actually part of the T-SQL, or actually the SQL language, not even T-SQL. They are part of the SQL standards that are out there, and every vendor can choose to implement or not the functionality. And Microsoft implemented I'm assuming most of the functionality. I haven't really gone out and tried to read all those standards. I know there's some things missing, but so what I'm talking about today is Microsoft's implementation in SQL Server of these window functions. So what makes these different is that they operate over a set or a window of rows. And I always kind of think of it as I pretend like I am a row in a set of rows that are coming back from a query. When I'm on a particular row, I can look through a window and perform a calculation. And that window can be different depending on how I've set my function up. You will always see an over clause when you are working with window functions. And there's one other situation that I know about that has an over clause that's not a window function, and that's the next value for function when you're working with sequence objects. I don't think those are too popular. I haven't seen them used too often. So, but typically when you see an over clause, that means you're probably working with a window function. And early in the beginning of this, years ago, I found that I would ask people in the room, are you using window functions? And just a couple of hands would raise. And typically, if I said anyone using row number, half the room would raise their hands. So there's a lot of these functions out there that folks use, and they may not even know that they are in this special group. And I didn't even know until 2012. And they were originally introduced, some of them, in 2005. So that over clause, I'm going to talk, I'm not sure if in this particular set of slides, if I drill down, I can't see my next slides coming up, but that over clause defines what that window looks at. When I'm on that row, looking through my window and performing the calculation, that over clause will define which rows I see, okay? So it's really, really important. Window functions can only be found in the select or order by clauses. That's the only places that you can put them, because they actually operate after these rows have been gathered. Okay, so the engine has kind of got these rows ready for you. And I know this is kind of a real simplistic way to think about it, but it helped me understand, and hopefully it'll help you understand how these operate. So we have everything done. Oops, let me go back. Everything done, like our where clause is already operated. If there's any grouping, that's been done. If there's a having, that's been done. All of that has already been completed. And we've got these rows, and now we're going to perform calculations on the rows that are coming back. Okay. Microsoft has always talked about how these, and I've heard other places, how these really improve performance. That's true in some cases. However, they definitely make queries easier to write. For example, in one of my other talks that I give, Modern T-SQL, I talk about some of the queries, the way they were written pre-2012, often resorting to cursors or some weird techniques to get some of these queries to work. And now with windowing functions, they are easy. And you'll hear me say window, windowing, and windowed. That's synonymous kind of in this discussion. Sometimes I'll say window meaning the window that we're looking through, but as far as a group of functions, you know, window, windowed, windowing, all the same. They definitely make queries easier to write when you're working on some tricky problem. So as I mentioned, back in 2005, we first had the ranking and window aggregates. So ranking functions are like row number, rank, dense rank, intile, and window aggregates was the ability to take your favorite aggregate function, add an over clause, then you didn't have to use a GroupBy. Okay, so that's what we got in 2005. 2012 was really a wonderful release of SQL Server as far as I'm concerned, because there was so much added to the language. Some of it didn't perform that great. Some things like some format functions and some other, what I call the easy functions, they don't all perform great, but as far as the windowing function, we got a lot added. So I'm really excited about that release, and I really feel that was the best thing that happened to T-SQL probably since the beginning of T-SQL, probably the best thing. Microsoft hasn't added any new functionality. There is other functionality that they could add. They haven't done it. But in 2019, they did take care of a couple of performance issues. Unfortunately, you've got to be on Enterprise Edition to take advantage of them. But it is, I was happy to see this, and I'm hoping, like Microsoft sometimes does as time goes by, sometimes they move features down to standard. So I'm hoping that that happens. So yeah, I do have something on the over clause here. So the over clause can contain several things. One thing that you can always add to an over clause is partition by. It's always supported, but it's not required at all. It's just required depending on what you're trying to accomplish. So basically what this means is that I want to perform the calculations on a certain group of rows. I can tell the window function that by this partition by. I want the calculations by certain by customer ID, or I want it by date, or whatever it is. There's also an order by clause. So this one is required for some functions. So if the function needs to know how the lines need to be lined up, so things like lag, things like row number, they're going to have an order by. And the order by can be different than the order by on the entire query. So they don't have to be the same. And there's also the frame. Some functions require the frame. However, you don't have to type it out. If you don't type it out, you get the default frame. And that's where some performance issues can happen. That frame, I kind of think of windowing functions is like a window that you might have in your house. I have a window over to the right of me, and it's got 4 panes. Those are kind of like partitions, okay? If I had a stained glass window, that'd be like a frame where I have tiny, tiny little bitty windows inside there. So we'll talk about especially the framing later on. Whenever you're talking about performance, there are one of the things you look at will be execution plans. Okay, those are really important. They don't always give you the best information. Sometimes they lie to you, and especially with window functions, there's some situations that the execution plan does lie to you. But if you see these two operators, the sequence project or the segment, you don't really have to worry about those. Those are just telling you that, hey, you're either using, this is the calculated column, you'll see that. I'm not sure always with window functions, but I have seen it a lot. Or if you are using partitioning or ordering, you'll see the segment. Here's where you've got to watch out. Sorting. Sorting often has to be part of your window function. That can be your bottleneck. So you have to watch out for that. You may just have to put up with it, okay? Also these work tables. So under the covers, the engine will create some work tables sometimes. And if you see table spool, that's always bad news, unless you're just working with a tiny little bit of data. Table spool is not going to scale very well. Okay. If you see a window spool, that's one of those situations where the execution plan can lie to you. The window spool theoretically is like a work table created in memory. However, in certain situations, it will be created on disk instead. which is where the table spool is created. So this window spool, this is something that we want to see, but you can't tell from the execution plan whether or not it's created in memory or on disk. And if it's created on disk, typically you can run into some performance issues. There's also a new operator, this window aggregate operator, which is really good news. And you'll see that with some of the updates with 2019. I think you can see it in some situations in 2017. So I'm going to go ahead and jump over to a demo, and then after that, I will open it up for questions. We just got a little setup, make sure that the execution plan is on. And what I'm going to do here, not quite done. What I'm going to do here is, well, first of all, I just want to show you an execution plan. This particular query has row number, a window aggregate, a running total, and it's got a lot of different operators because of that. And just to show you real quick, I don't want to spend a lot of time in here. You can see that window spool. There's the segment operator, the table spools. There should be some sorts in here somewhere. There's a sort. So you can see it's pretty, it gets kind of complex with all that, even though that's not even a join. There's no where clause, it's just a select from one table. And we have that complicated of a plan because of these window functions. So what I'm going to do is I've got a few queries that I'm going to go through step by step and take a look at how we can fix them. They are simple queries just from the AdventureWorks. Okay. And the first thing, I don't care about the results, but I guess I could have just turned that off. I do care about the logical reads. That's really important, especially since the execution plan will lie to you. So for example, when I am running my ranking function, my logical reads, I've got a 0 for a work table, and I've got 689. Well, this is a really small table anyway. Okay, all the AdventureWorks tables are small. But take a look at what happens for the window aggregate function. I still have that same number of logical reads just to read the entire table because there's no where clause, but the logical reads is really, really high. So that's telling me that if I am running this window aggregate function on a large table, I'm going to run into some issues. It's not going to scale. I also have a large number of logical reads on the running total query. On my favorite function lag, absolutely my favorite function, I'm back to good performance again. Okay. And first value is another one kind of related to lag, but look, it's got a really high number of logical reads, and the statistical function also has a high number of logical reads. If I look at so I can tell from the logical reads which query performs the best. Doesn't matter on a small data set like this, but if it was a large amount of data, you would feel the pain on some of these queries. The interesting thing is that SQL Server is just saying that they have about the same performance, even though I know that they don't, okay? But you can see we've got window spool, like I talked about, we've got sorts, and typically in here, at least the execution plan is saying that the sort is the bottleneck in all these queries. It does impact, it is in some of them, but in others it's not. And I'll show you how we can Well, the way we can figure that out is like here, where we've got the sum over, it's saying that the sort is just, is 62%, and this table spool is only 2. I can really tell you that the table spools are the bottleneck in this query. That's where the problem is. And I can tell that by looking at these logical reads, okay? So that's how I can tell. So I think that's all I want to show you in this demo. So Matt, are there any questions at this point about anything I've covered so far?
No, there was a comment about not realizing you could leave the over blank inside the parentheses. But other than that, it's been quiet.
Yeah. Okay, so you can leave it blank. You can. Did I do that in here?
I believe so.
I did.
Or referred to it.
Empty over clause. Here it is.
There it is. Yep.
I like to call this the empty over clause. And so that's a great question. So this one is a window aggregate. So I can use this to get, like, if I'm using sum, I could get like subtotals. If I put a partition by in here, it would give me subtotals. If I don't have that in there, and so what I could do, let me just copy this and just run that one by itself. And I can go a little slower in this because I know this is an hour session, and I think I've got like an hour and a half or something.
We did just get a question in, and it's I suspect it might be a lengthy answer, but it is, what does a spool do? So I think wanting more information about spools that you had referred to there.
Just show you this one first before I jump to that one. So what this one is giving me, since I've got the empty over clause, is a grand total over the entire set of data. Okay, so hopefully that answers that question. So the spool, from what I understand, and I've even looked back, you know, Grant Fritchie has all his books that are like 5 inches thick on performance, looked in there. What only thing I understand is that they are similar to temp tables, but they are not something that you can select directly from. So they're work tables that SQL Server is creating, if that makes sense. And I know there's probably a lot more to it than that, but for these purposes, that works. And I've, you know, gone out and tried to learn more about it, and really had, and it's been like a year since I've tried to do that, and really didn't run into much more than that. So in order for SQL Server to perform these calculations, it has to create some work tables to do it. Kind of like if you had a really complex, query to write, sometimes breaking it down into smaller pieces, like a couple of temp tables, and then joining them, sometimes performs better than doing the complete join to begin with, but, you know, with directly. Anything else?
Q&A panel is clear and chat is clear as well. So I think you are good to go back into it.
All right, I'm going to jump back then. I have like this little gnat bugging me. So if you hear me hit the computer, that's what I'm doing. Killing the little gnat. All right, so this is what we've done so far. I've got all the different types of window functions, and actually Microsoft groups first lag, lead, first value, and last value, and the statistical ones. They dump all of these into one category called analytic. And I like to separate them out just because they do work differently. So lag and lead and first value, I call them like offset, but they can definitely be used in analytic queries for sure. But since they do work so different than the like percent cont in some of those, I kind of separate them out when I talk about them. Whoops. So that's what we've done so far. Ranking, lag and lead, have pretty good performance. The rest of them had those ugly high number of logical reads. We know there's some issues. So the first thing that you might do is look at indexing. And I'm not sure if Itzik actually came up with this. I think maybe he did, but I learned about it from one of his books. And he calls it the POC index. Basically, you want to add in your index, the partition by columns, your order by columns, and then add any covering columns. But he said if there's any filter, go ahead and put those up front. Sometimes this helps. Sometimes it doesn't help, because if I add, for example, if I add filtered columns first, I'm still going to need to sort. So I may not eliminate the sort, but if it can be covering. But before you go out and create this index for every query, don't do that. I like to give advice on indexing, but I don't like people to go out and just start creating a ton of indexes, because indexing is an art and a science. And I've seen places that have had 20 indexes per table, and can't even, SQL Server couldn't even figure out which queries were the best ones to even use. So I'm just going to give you this information and show you that it does help. And if you really, really need to query tune something that has a windowing function, this may help. Let's take a look at that. Yeah, I always hate to give indexing advice because I'm afraid of what people will go back and do. So, all right, so I'm going to compare the same queries. I don't see. Nope. Okay, demo 2. I'm like, something is not right. I scrolled back to answer that other question. Okay, so I'm going to create a POC index. So all of these queries have the same partition by, they're all partitioned by customer ID. If they require an order by, I'm using sales order ID. Okay, so here's P, customer ID. Here's the order by, sales order ID. Here's my covering items, and I don't have a where clause. So that's how I figured out that index. So I'm going to go ahead and run this again, and I'm saving, I've included the number of logical reads that we saw before. And luckily that doesn't change unless indexes are changed or the data's changed or something changes. All right. So our ranking function before was pretty good at 689. Now it's even better at 119. Why is that? It's because all of the data is coming from this index, which is a smaller object. Okay, we are still pulling all of the rows, but it's a much smaller object. So SQL Server has less to look at. The window aggregate, I get the same benefit here, but I still have that really exactly the same logical reads on that work table. And that's that table spool. Okay. On the running total, same thing happened. I got benefit of the query, but I still have my problem here. The lag function, my favorite, the logical reads, 119. So it benefited just like the ranking function did, but I still have, every place that I had a high number of logical reads, I still have that, okay? If I look at the execution plans, like in the very first one, I can see, now it says 5%, which is probably pretty accurate, might even be smaller than that. You can see that that sort is gone. So I've eliminated the sort out of all of these. However, real life queries, it probably is not that easy to eliminate the sort, because most queries are going to have where clauses, and they're going to have, you know, multiple tables and a lot of different techniques. So just in this simple scenario, it did eliminate it. So are there any new questions?
There are not. And now that my mute button is acting nice, I'll answer that faster next time.
Okay, that's fine. I always know to wait a little bit. So
it just wouldn't come off mute, and then it decided to. So that was good.
Okay, cool. I'm going to jump back over here then. So at this point, we have really improved the ranking and lag and lead queries because of adding this POC index. We've got a little bit of improvement in the others. Okay, so what's the next thing that we can do? Framing. This is where we turn our window into a stained glass window. All right, so framing is a topic that I didn't even want to learn about at first. It was just very scary to me. And the book that ITSEC put out, years ago, that particular chapter, I read it over and over and over until I got it. So I know he's way smarter than I am, but it just is a hard topic, I think. Luckily, this does not apply to most of the windowing functions. It's only needed in moving aggregates. So what's moving aggregates? Like running totals, 3-month moving average, those types of things. And also first value and last value. And in fact, like I said, you don't have to specify it in many cases, but there are some situations where you have to use it, like in last value or with your 3-month running average, your 3-month moving average, you have to get the right results. So there's a bunch of terms, and what I suggest is don't try to memorize them, in the few seconds that I'm going to have this slide up. You may have to go out and just get some practice. I'm pretty good at it after, almost 10 years of working with this, but just take your time and just try to understand it. And you'll just have to go back, maybe download the slides, which are out on my GitHub, which I think the link is in one of the slides at the end, but if not, I'll provide it. Download the slides and go over it again until you get it. So what do these mean? So rows is a positional operator used to define the frame, okay? Range is a logical operator used to define the frame, and it's the default if you don't specify something. So what in the world are we talking about here? Well, I didn't really talk about like the difference between row number and rank, or row number and dense rank, but rows only cares about the position of the row based on that order by in the over clause, okay? It only cares about where it lands. Range also cares about the value, all right? And range is not fully implemented. This is one of those things that Microsoft has not fully implemented because it's really meant for dealing with time periods, which, this functionality is not baked into SQL Server at this point. Unbounded proceeding means the first row of the partition. So either the first row of the partition, if you're using partition by, or the first row of the data set, if you're not. So if I have 10 rows, row 1 is unbounded proceeding. I think I should do that the other way, some backwards to you. Unbounded following is the last row of the partition. So if you have rows 1 to 10, it would be row 10. And current row is the row where the window function is being performed. So the interesting thing about framing is that every row will probably have its own window to look through. So previously, on my other functions or other things that we've talked about, when I look through the window, if I'm using partition, I'm only going to see the rows in my partition. Okay. Now I'm going to define this even more granularly. All right. When I look through the window, I may have my own special window just for my calculations. So the most common is called rows between unbounded proceeding and current row. If you don't specify the frame where it's needed, SQL Server will use range between unbounded proceeding and current row. All right. There's another difference. Between rows and range that I didn't mention. Let me just go back. Rows typically creates a work table in memory. There are evidently some situations where it doesn't. I have not run into those. I think it has to do with like the really, really large number of rows. I haven't run into that situation. Range will create the work table on disk. And in the execution plan, it will show you, it'll tell you that it was a window spool when it really isn't. So this is a big deal here. If I don't specify the window when it's needed, range will be used, it will give you worse performance. So it's worth learning this terminology and making sure you've got the frame. All right, so I'm going to talk about frames. Rows between unbounded proceeding and current row. There's also a shortcut method for this particular one. I think it's rows unbounded proceeding. I kind of don't like to use the shortcut because they don't all have shortcuts and it doesn't really tell you exactly what's going on. So what this is saying is all the rows starting at the very first row in my partition and up to the current row. So if I'm doing the calculation on row 1, I will see just row 1. When I'm doing the calculation on row 2, I will see rows 1 and 2. Okay, so this could be like for a running total. If I'm on row 3, I will see the rows 1, 2, and 3, and so on. I can also have one called rows between unbounded following and current row. So this could be used for a reverse running total or for the function last value. So if I use this one, then on my very first row, everything between that row and the first row is the entire partition. And as I move, the frame gets smaller. Okay, the other one, the frame got larger. This one, the frame got smaller. This one is used for those moving calculations, like 3-month moving average, rows between, and the calculation's a little different, and range is not supported. So you have to do this one right, or you won't get the results you expect. Rows between 2 preceding and current rows. So if I'm on row 1, I just see row 1. If I'm on 2, I just see 2. If I'm on 3, I see 1, 2, and 3. And so I don't see the entire 3 months or 3 weeks or whatever it is until I'm on row 3. And then as I move, you can see I just have 3 rows. It just keeps moving. Okay. All right, jump over to the demos again. And I am going to, I'm not going to run row value, or I'm sorry, row number or lag anymore. But I'm just going to look at the ones in this particular section that do have to have, let's see. Oh, I'm not doing it exactly the same way. So I'm looking at just sum over with order by here. So this is how I wrote it earlier. Okay. Now I'm including a frame. However, I'm using range. And as I mentioned, range is not the best performing. So these queries are identical. Absolutely identical, because this is the default frame. So when I look at the logical reads, I still see a high number of logical reads, and that should match the running total that I showed you earlier when I was comparing all the different kinds. I look at the execution plan, it says I've got a window spool. It does say 34%, but I would bet it's probably a lot higher than that. My sort is gone because of that index we added earlier. Okay, so that's what you get by default. If I would add rows between unbounded proceeding and current row, if I took the time to do that, I now get my work table, 0 logical reads. And now my execution plan is actually telling me more truth, really. Now let me do something else. Let me just run these two together. One with range, one with rows. And in this case, they'll give me the same exact results. However, you can see with range, I've got that high number of logical reads. With rows, I've got 0. If I look at the execution plan, as far as SQL Server is concerned, these are equivalent as far as the execution plan. They don't look exactly the same. There's a little bit of difference somewhere, but they think that they're equivalent in performance. But in this case, let's see, the first one, I believe, when it's really on disk, so this one performs a lot worse. Also, need this in with first value and last value. So here's two queries with first value. One without the frame specified, one with the correct frame specified. And without the frame, you can see the high number of logical reads. With the frame specified, 0. Again, the difference is rows versus range. I look at the execution plan. Again, they're telling me equivalent performance when I really know that they're not. Range doesn't work with in proceeding or the in following syntax, so we can't make the mistake there. So if I try to run these, I'll get an error message telling me range is only supported with unbounded and current row frame delimiters. Okay, so it's not, doesn't, work. Let me just run this one by itself, and you can see that it has a low number of logical reads, and we've got the window spool. It is telling us the truth that time. I don't think I have an example. There's another problem with, there's a couple more problems with range. Number one, if you were using last value, you would not get the correct results. So let me go ahead and do that example since I do have a little bit of extra time. How much I have like not another 20 minutes. I have more than that, I think, right, Matt?
Yeah, so it's a little open. Yeah, I think the next session window begins at 5 Eastern, and you can go all the way up to that if you'd like. I think they left that in there for Q&A or just people to hang out, or if there's that much stuff, then go all the way to that. But yeah, the next session starts at 5, and I have a very hard stop then too. So I would say you'd
Okay,
have to
I'll
stop by then.
stop
Yeah.
by then. Okay, so what I'm going to do here is just do another little example showing you last value, which last value is supposed to give you the last value based on the order. And let me change that to. And since I didn't specify the frame, it's not going to work. So if I look at this customer, is it working? Did it change without me? Let's see. It's giving me the first value, which for some reason, oh yeah, okay, my brain had to think first what it's doing. It's not giving me the first, it's giving me the same value. So notice it's giving me the same value each time. And why is it doing that? Is because the frame is unbounded proceeding to current row, and current row is the last value in the frame. That's why. So if I change that, rows between unbounded following and current row, why does that have the wrong syntax? Unbounded following and current row. Seems right. Don't type in demos. Unbounded. Okay, well, I'm not going to do that then because I'm not going to troubleshoot. Rows between unbounded following and current row really seems like the right thing, but I must have it wrong. But anyway, you have to have it similar to this unbounded following. Okay. You have to have the correct frame to get the right results with last value. And obviously I have forgotten something. Other thing, which we'll talk about, we talked about the running totals, right? If there is a tie in the data, for example, in this case, I use the order ID, which was unique, but if your order by in the over clause is not unique and you have range by default, you can get some weird results because the range will see those values as the same and it'll create the same windows. So I am going to, that's really bothering me, but oh, this one, but I'll figure it out later. So there are some logical differences if you leave the frame out or don't do it correctly. So are there any questions, Matt? Probably somebody's figured out what I did wrong here.
So nobody's okay, so there are
it's
2 questions. And then yeah, it just popped into the chat here. It just says between current row and unbounded following. So I think
somebody figured it out.
Yep.
Right as I figured it out. Okay.
There you go.
There
So
we
there,
go.
yeah, so 2 questions. One from John is any window function or analytical function that is not available to standard edition. It says, for example, SQL 2016 standard. So are there any enterprise only versions of this that, or of these that
Of the functions
you're aware of? Yeah.
No. However, there's some performance implications that I'll talk about that are enterprise only.
Okay. So supported syntax, but may not be as cool and fancy and fast.
Yeah, exactly.
Okay, then the other one from chat is, what's your advice when using window functions with memory optimized tables, especially with regard to suitable indexes?
Whoa, memory optimized tables. I haven't really done much, really anything with memory optimized tables. So I don't have the answer. I don't even know if they're supported with them. I would assume so, but I haven't tried it. So I will write this down. And I don't know if somebody else in the audience has worked with them and might know the answer.
We have some memory optimized tables at the shop that I'm at, but we don't use a lot of window functions in our code.
Yeah.
So I haven't really exercised that.
Yeah, and I can't even remember. So memory optimized tables are the queries. I know there's some differences like with stored procedures and the way you create the table. But
yeah, I wonder if that would
the
make a
queries?
difference there, if it was a natively compiled stored procedure versus not. So I don't know. That's it sounds like it'd be an interesting blog post.
Yeah, it does. I wrote it down. So it's basically indexing. So how to like use your indexing strategy if you're using window functions with memory optimized tables is really
Yeah,
the
basically.
Okay, I wrote
Yeah,
it down. I wrote it down because I do not know the answer.
cool.
Yeah.
Q&A and chat are once again clear. So back to you.
Okay. All right. So here we are. So far we've performed, we've added the POC index, and we've added a frame which helped with the moving aggregates and helped with first value and last value. Okay. So those are good right now. They will scale. You won't have problems with them. Really, that frame is really, really important in those situations. Okay, so we still have some other issues. So what else can we do? If you're working on pre-2019, that's really as far as you can go. So, oh, I guess I have some little animation there. Still have some problems. 2019, we have this intelligent query processing feature called batch mode on row store. And batch mode, if you're not sure what that is was introduced with column store. Okay, so storing the tables or really the indexes a different way to really cut down on IO and really allow faster processing, like on aggregates. And it was only, batch mode was only available with column store previously. The query had to have column store to get this advantage. So what I found was that, well, what happened was in 2019, as part of the intelligent query processing, Microsoft added this batch mode to row store. So you didn't have to have a column store index involved in your query to take advantage of this batch mode. And it helps the two types of queries that we still have problems with, window aggregates and the statistical functions. It doesn't always work. You won't always see it, but it looked to me like it kicks in around 100,000 rows in your results. All right. And I also saw that it didn't really make a difference as long as logically it was correct. It didn't make a difference as far as whether I included the frame or not. You know, as long as logically it was okay. So let's go ahead and so what I'm going to do is create a bigger table because those adventure work tables are really small. A lot of times I will use Atom Mechanics Thinking Big Adventure tables, but they're a little bit more than I want for this. I'm going to go ahead. So basically all I did was union the sales order detail table. And I'm going to create an index on here, a POC index that will help me. And we're going to look at the aggregate query, which is the sum over, there's no order by. So this is where we can add aggregates without adding a group by, or add an aggregate at a different aggregation level. Really, really useful, but they just don't scale. Also an analytic function, %rank. Under the covers, and I did this, figured out how to duplicate all of the analytic functions, there's 4 of them, how to duplicate those with just regular formulas without using them. And what I found was the analytic functions are actually using the window aggregates. So that's why there's an issue. All right, so if you take a look at this point, I'm seeing this large number of logical reads. You can see how it gets worse and worse. This is about maybe not, I can't remember if we were 400 some or 600 some logical reads originally. And you can see how this just really gets large really fast, this logical reads here. All right, so all I have to do, in this case, let's see how many rows. This has got 485,000 rows. All I have to do is upgrade to 2019. In this case, I'm just switching the compatibility level. I'm going to rerun these queries, the same exact queries, on the same table. And it seems like it's still taking a lot of time. I think most of that is because I'm populating this grid. The grid takes a while to populate, so you would see it much faster. Or if we had, if we weren't populating the grid, it would be better. Okay, so the table scan, 908 logical reads like we saw before. Now we've got that great work table in memory, like we like to see. The same thing with the analytic function. So that fixed it without me doing anything, without me adding any indexes, without me changing the code. And if I look at the execution plan now, instead of seeing the window spool or table spool, now I see window aggregate instead. So I really love seeing that. If the query doesn't take advantage of it, it will still show the old one, I believe. And here with the %rank, I see 2 of them. So it probably under the covers, it had 2 different, possibly 2 different window aggregates in the formula. So there is a hack that works with 2016 and up. You still have to be an enterprise edition. So I'm going to put the compatibility level down where it was before. So the hack is that you create an empty column store table. Columns, in this case, a column store, create a table. It's a temp table with a column store index. Okay. So do that. And then we know that we should get crummy performance. All I'm doing here is just outer applying this column store table. Again, it's taken a lot because there's a lot of rows to be returned. And in this case, our logical reads are 0. So we're getting that batch mode in an older version of SQL Server. However, it seems like it's a lot of work to do that. All right, let me go back to the slides. Where'd they go? Do we have questions at this point? That was a really fast demo, but there's not that much to it.
Nothing in the Q&A or chat windows as of now. Yeah, I will let you know if anybody tosses one in there. They may still be absorbing that one.
Okay. Well, all it is basically if you are on 2019 Enterprise, you get you know, you get better performance for free. Basically,
It's always nice. Yeah.
Yeah, or if you're on Azure SQL database, I'm assuming Azure Managed Instance, you get the better performance free. All right, so now we've improved the performance of everything. Everything's able to scale, everything's looking good. So let me just pop back over to the slides. So one of the things that people ask about is what can I do if I have to use a window aggregate or the query lends itself to do that? Well, sometimes it's better just to use an older technique. So if I want to use sum over, maybe it would be better if I didn't. All right. So here's one thing that you could do. In this case, I'm using a common table expression. You could use a derived table. You could use a temp table, but I'm just pre-aggregating. So I want to get, let's see what I've got here. A subtotal on each sales order ID. Okay, so I could do that much easier with a window aggregate. However, if that was a lot of rows, it would not scale. So in some cases, it's better to back off. You know, if it is a window aggregate, it's often better to back off. So see, this is the same thing. However, the performance is a lot worse. If I let's just look at this really quickly before I run it. This one had logical reads 1816. Here's the same query and logical reads 700,000. So in a case like this, even though this is really easy to write, it would be better to back it off and use, write it like this or some other method instead. Another thing with these is if your query, what you're doing is a little bit complex, there's multiple steps to it. If you can pre-aggregate, if there's a way that you can pre-aggregate earlier in an earlier step, so by the time you get to the end and apply the window function, that's also a good method as well. So I'm going to pop over here and just kind of show you. I don't know if there's any questions before I talk about this. This is the bonus material because this session is typically an hour long. So we're on bonus material right now.
No questions. Okay. Yeah, nothing new.
Okay. So recently I decided to write an article comparing some older techniques to windowing functions. And I started with lag because that's my favorite function, and I never got past lag. And these were the results of all these different methods that I used. And notice that for a particular query, it was a little more complex than what I've used in this session. But the time on it was 300 milliseconds, 365 logical reads. And you can see that all of these other methods, none of them did as well. So at one point, I decided to break it down and use a temp table. So here I had an outer apply instead of using lag. It went from 12 seconds and 86 million logical reads by just using an index temp table instead of writing it all in one query. I was able to get it down to 700 milliseconds, which was almost as good as lag. So I'm just going to show you these really quick. And if you go out on Simple Talk, probably bring that over and show you the article. Oops. Bring it over once I find it. Wasn't that long ago that I wrote it. Here we go. So here's the article if you're interested, and I'll just pop that into the chat. In case you're interested in it, did I hit enter? Whoops, I don't want it to go, I want it to go to everyone. Here we go. All right. So I wrote the article if you're interested. But what I did, just to come up with some additional material, is I included all the code inside here. So you can see that I've got a little bit more complexity, still not a terribly complex query, but it runs really fast if I use lag. One of the older methods, I'm not going to run all of these, but one of the older methods would be to use some kind of a self-join. So basically what I'm trying to do is compare orders for, I guess on the product, partition by product, how many days between orders on a particular product. So to do that, you would typically have to do a self-join. So this is the way to do it with lag. It's actually the easiest of all the methods. If, to do a self-join, let's see, I'm joining on the table here. So I'm joining on sales order header, sales order details. So I'm joining on both of those tables twice to end up with this. And, as you saw in the slides, this one actually didn't even give me the correct results. I don't think I had that in the slide, because typically I would really need a left join. And if I did a left join, it wouldn't finish running. It just was running for minutes. So I had to just get rid of like the day that there was no previous data compare. Here's using derived tables to do it. And again, I'm using left join, which I should have on the other one, but I really couldn't. And so inside here, let's see, that's just the query itself. And then I have to compare order dates. That's what kills you with these. You have to join, but then you have to compare order dates. So while it does give the right results, it takes a long time to run. Probably similar results to a common table expression. It's just written a different way. The outer apply is what I really thought would give great results, but it didn't. It didn't just like this. It was really, really bad. Again, it's this comparing on the order date. I'm finding the max order date that's less than the current order date. That kills the query. It really does. By creating the temp table, I just created a temp table of the data I was working with. And that really made a difference. And so I went back and compared. So then with the temp table, the outer apply, oops, I'm going to create the temp table, I guess. With the temp table, the outer apply did perform almost as well as lag did. So you can see there's still a relatively high number of logical reads. So I did a lot of, let's see, that was the temp table with outer apply. Oh, and then I guess I added an index to it, made it better. The self-join with the 10th table was better. Tried a scalar UDF. It just, I had to kill that one. I tried using a function call. Oh, there's where I did the function call to UDF. Really was bad. I tried an inline table valued function, also still really bad. Tried the cursor solution. First, I was getting really bad results, and I was thinking, I feel like it should be better. You have to turn off the execution plan. Otherwise, you get an execution plan for each loop through the cursor, and that was causing performance issues. So it actually did not take too long to run. But I found that was pretty interesting. But if you go out and take a look at that article, you can try all that for yourself. But yeah, the cursor took 2 seconds. So again, I had to turn off statistics IO, and I had to turn off the logical or the execution plan to really see that, to get it to run, pretty well. So it was not too bad. And I'm not saying go out and use a cursor. I'm not saying do that, but I included that just because I knew it was a way to do it. And back before 2012, it was probably a pretty good method to solve a problem like that. I've also got some other timings that I did. I think it was on an older laptop than I'm using now. I took Atom Mechanics Thinking Big Adventure tables and did some testing on 30 million rows on the window aggregate. So if I was working in 2017, it took like 5 minutes to run the 30 million rows. If I did the window aggregate, if I changed it to a common table expression, or you could use a derived table if you like the nested table, if you like that better, it only took 1:75. Upgrading to 2019, it was 1.5 minutes, no matter which method I used. So it was better in both situations. So that was pretty good. The running total performance, 36 minutes in 2017 to run with the default frame. So if you don't specify the frame, you get the default frame. If I specified the correct frame, it took 3.5 minutes. Upgrading to 2019, I got the same performance no matter what I did. So I thought that was pretty interesting. The caveat is that if for some reason you don't get the correct logic by using the default frame, that could happen. I have some resources for you. And I'll just, oops, that. I'm going to put this also in the chat. I don't have the bonus stuff in there. You can get that from the article that I showed you. So I mentioned Itzik's book a couple of times. He has also written a second edition, but somewhere along the line, I decided that I could also write a window function book. And I have also have a second edition that came out. And I'm going to say mine's pretty good. I think they're both really good. I feel like I explain things in a different way than he does. And obviously I have different examples, but I did learn a lot from Itzik. And I feel like I wouldn't be where I am as far as understanding these without his help initially. I do have a Pluralsight course out there. There are articles on AuntKathySQL.com, but now that I've worked for Redgate, I barely have time to look at my own website. There are quite a few Simple Talk articles. I just put the GitHub link if you're interested in the slides and the code, and also my email address. So really, that's all I've got, Matt. If there's any other questions.
There are
Questions. There is a thank
the blog post comparing the methods.
There is a what?
There is a thank you for the blog post
Oh.
comparing the methods. Yeah, I think something
Oh, you're
happened
welcome.
with my headset.
Okay.
Hopefully you can hear me now.
I can't. I could hear.
Okay,
It just didn't register in my brain what you were saying.
got it.
Yeah. So that was just. I'm gonna probably do that as well with some of the others pretty soon. But man, that one on lag, it was just really. I just couldn't believe how many different ways there were to, write the same query.
Yeah, yeah,
It was pretty amazing. There
yeah.
might be other ways I didn't think of.
Yeah, well, and it's always, those are almost always my favorite kinds of posts, is when there's, kind of real data attached. Like, I did this and it took this long. I did, that and it took that long. Because those, not only are they informative, they help settle arguments. Where, let's say a dev says, well, I read, such and such, and they said that always, way X is better.
Always, that's a bad word.
Right. And the blog posts they were read, likely didn't have this kind of information in it. It's just somebody saying, well, I used it and you should always use it too. So yeah, having that comparison is helpful. As I do sometimes have to settle those arguments between my team and devs and
Right.
engineers. So yeah. Handy.
Yeah, exactly. So my other session that I give sometimes called Modern T-SQL, I say, exactly that. Everything in your T-SQL toolbox is useful. Don't get stuck doing one thing. You might have your favorite thing, but you're going to have to back away from that if you hit a performance issue.
Right. Well, yeah, I think that's a really good tip, is just be flexible with the way that you attack an issue. And that's sometimes where that second set of eyes can help too, is we all have our habits, right? And sometimes it's like, I can't get this where it needs to be. And it's just because you're kind of tunnel visioned on your preferred way. So it's always nice to bounce it off somebody, whether it's on the SQL help hashtag or on your team or in community Slack or wherever, really.
Yeah, that's true. That's true. Yeah, and it's really fun. I don't really get to touch real data much anymore. Which